Okay, let's dive right into this. By the end of this lesson, you'll understand how investment risk is measured, why standard deviation is one of the most important concepts in the CFA curriculum, and how correlation explains the benefits of diversification. Let's get started.
To build a rock-solid foundation today, we're going to cover 5 quick things. 1. Measures of central tendency. 2. Dispersion and risk. 3. Normal distribution and skewness. 4. Covariance and correlation. And finally, 5. Today's key takeaways.
All right, Section 1, Measures of Central Tendency. Finding the middle. This is where we figure out exactly where our investment data is centered, which is, the absolute bedrock of our return expectations.
So when we're talking about central tendency, we're usually looking at 3 main things: the mean, the median, and the mode. The mean is just your standard arithmetic average, right? And the mode is simply the most frequently occurring value in your data set. But the median, that one often helps to actually visualize. Picture the median on a massive highway. It's got an equal number of lanes on either side. Well, the statistical median sits perfectly in the middle of your sorted data just like that. Once you line up your investment returns from the absolute lowest to the highest, the median is that exact halfway point with an equal number of observations above it and below it. Now, once we've got everything sorted from lowest to highest, we don't have to stop at the median. We can actually slice this data up even further. We can divide the whole distribution into sections. Quartiles carve it up into 4 equal groups, quintiles give you 5, deciles give you 10, and percentiles slice it into 100 equal pieces. Now here's a highly testable concept for you, the interquartile range. This is just the difference between the 3rd quartile and the 1st quartile. It's great because it gives us this really clear picture of how spread out the middle 50% of our observations are, completely ignoring those extreme highs and lows at the edges. Let's take a really quick mental pause here to lock this in. If the median is exactly in the middle of our sorted data, what percentile does the median represent? Take a second. Okay, if you said the 50th percentile, you hit the nail right on the head.
Moving right along to Section 2, Dispersion and Risk, Measuring the Spread. Knowing where the center is great, but we also absolutely need to know how spread out our returns are around that center. Because in finance, dispersion basically translates directly to risk.
Now, standard deviation is a 5-star exam topic. It's one of the most vital risk measures in the entire CFA curriculum, so pay close attention here. First, let's look at variance. Variance measures the average squared deviation around the mean. But since it's squared, the units are kind of weird and hard to interpret intuitively. So what do? We take the square root of the variance, and boom, we have the standard deviation. Picture a tall, narrow curve. That means the data is tightly packed around the mean. Low standard deviation, low risk. Now compare that to a flat, wide curve, where returns are just scattered everywhere. That means high standard deviation and a lot more risk. You absolutely must be able to visualize that relationship on exam day. But hey, standard deviation isn't the only way to measure spread. You've also got the range, which is literally just the highest observation minus the lowest. Simple enough. Then there's the mean absolute deviation, or MAD, which gives you the average absolute distance each observation lies from the mean. But the one I really want to highlight is target semi-deviation. See, standard deviation looks at the whole picture, the good upside surprises and the bad downside drops. Target semi-deviation, on the other hand, focuses strictly on the observations that fall below a specific target return. So, an investor who is purely focused on downside risk, they're going to look at target semi-deviation.
Okay, but what if we need to compare 2 completely different investments? To do that, we use the coefficient of variation. The formula is simply your standard deviation divided by your mean return. Basically, this tells you exactly how much risk you're taking on for each single unit of expected return. So your golden rule here, the crucial thing to remember for the exam, is that lower is better. A lower coefficient of variation means you are taking on less risk to earn each unit of return.
Let's do another quick check. Imagine you're sitting in the exam room and you're asked to compare 2 distinct portfolios using the coefficient of variation. Which portfolio is the superior choice? Think back to that golden rule we literally just talked about. Yep, it's the portfolio with the lower coefficient of variation. Never forget, lower is always better here.
All right, Section 3, Normal Distribution and Skewness, the shape of data. Let's see how all these building blocks actually shape the data distributions we're going to be analyzing.
You are going to see the normal distribution constantly. It's everywhere in finance. And the beautiful thing about it is that it's perfectly symmetrical. Because it's perfectly balanced, your mean, median, and mode are exactly equal, sitting dead in the center. Even better, this entire bell curve is completely described by just two simple parameters: its mean and its standard deviation. That's the whole shebang.
But of course, the real world is messy, and investment returns aren't always perfect bell curves. Sometimes they skew. If a distribution has a long tail extending out to the right, we call it positively skewed. If the long tail drags out to the left, it's negatively skewed. Now, here is a massive exam tip for you. The mean is always pulled toward the long tail. So if the tail points right, the mean gets pulled to the right, making it higher than the median and the mode. If the tail points left, the mean is pulled left, making it the lowest of the three. If you just remember that the tail pulls the mean, you won't have to memorize a bunch of complex inequality formulas.
So skewness looks at the lean of the data, but kurtosis measures the thickness of the tails. A distribution that looks pretty normal is called mesokurtic. One with thinner tails is platykurtic, but the one you absolutely need to watch out for is leptokurtic. For the exam, you've got to remember that fatter, leptokurtic tails mean a much greater probability of extreme, surprising outcomes. If a portfolio's returns are leptokurtic, relying just on standard deviation might actually lead you to severely underestimate the risk of a catastrophic loss. Time for our final quick check. Imagine a positively skewed distribution. So it's got a long tail extending way out to the right. Which measure of central tendency, mean, median, or mode, will be the highest? Think about that exam tip we just went over. Right. Since the mean is pulled toward the long tail, and the tail is on the right, the mean is going to be your highest value.
Moving on to Section 4, Covariance and Correlation, Relationships between Assets. This is arguably the most important section in this entire learning module, because you literally cannot build a properly diversified portfolio without understanding how different assets behave relative to each other. So, before we can even talk about the benefits of diversification, we have to start with covariance. Covariance is just a measure that asks, do these two assets tend to move in the same direction or opposite directions? If they generally move up and down together, your covariance is positive. If they move in opposite directions, it's negative. The big limitation here, though, is that covariance isn't standardized. That means looking at the raw number on its own is actually really hard to interpret.
And that is exactly where correlation comes in. Correlation standardizes that covariance. Now listen, you absolutely must memorize this formula. Correlation equals covariance divided by the product of both standard deviations. It is a 5-star, incredibly high probability exam topic. It gives us a crystal clear, standardized measure of both the strength and the direction of a linear relationship between two variables.
The absolute key takeaway for correlation is that it always, and I mean always, ranges from -1 to +1. A correlation of +1 means the two assets move perfectly in sync. A correlation of exactly 0 means there's no linear relationship whatsoever. And a correlation of -1 means they move perfectly in opposite directions. Think of a correlation of -1 like two kids on a teeter-totter. As one side goes exactly up, the other side comes exactly down. Finding assets with negative or even just low correlation, that is the holy grail of portfolio diversification because it smooths out your overall ride.
And finally, Section 5. Today's key takeaways. Summarizing Learning Module 3. We have covered a tremendous amount of ground today, so let's quickly distill everything into a few highly actionable takeaways for your CFA prep. First, focus your study time on conceptually distinguishing the mean, median, and mode. Second, remember that when you're evaluating risk per unit of return, a lower coefficient of variation is always better. Third, use our visual rule. Skewness always pulls the mean toward the long tail. Fourth, keep in mind that fatter leptokurtic tails signal extreme outcome risk. And finally, get incredibly comfortable calculating the correlation formula and remembering its rigid -1 to +1 range.
As you move forward into portfolio management, I want to leave you with this question. How will correlation shape the risk of your future portfolio? If you found this video helpful, please like the video and subscribe to Designation Buddy for more CFA learning modules. We'll see you in the next lesson, and good luck with your studies.